Okay, we're going to continue with relations and functions, and this will be part 3. So to use a mapping diagram to determine whether each relation is a function, if you recall that a function has, for every domain, exactly one or paired with one range. So looking at A, you have domain of 11, 12, 13, and 20. Since they are all distinct with no repeating values, going to a -2, -1, -2, and 7, you will see that that is a function. Looking at B, you have -2, -1, 6, and the -2 again. Since you have a repeated domain and it's going to a different range value, that would make B not a function. So this would be a picture of what the mapping diagram would look like. There's no value in A in the domain that corresponds to more than one value in the range, and so that makes that relation a function. And for B, the domain value -2 corresponds to two range values, the -1 and the 1. So it's not a function because we could not write a mathematical rule that would have the output different. If we write a rule, the output would be the same for that particular input. So to use the vertical line test to determine whether the relation is a function, remember to graph it. So you'll be graphing again like you did last night on homework. And you graph the ordered pairs on the coordinate plane. Then step 2, pass your pencil across the graph as shown. So this is kind of a review. So the vertical line would pass through 3, 0 and 3, 2, and the relation is not a function. So function notation, this would be something new today. So equations that represent functions can be written in a form called function notation. So the equation y is equal to 2x plus 1 can be written in the form f of x equals 2x plus 1. The symbol f of x is read f of x and can represent the value in the range of the function that corresponds to the value of x in the domain. For example, f of 3 is the element of the range that corresponds to the element x equals 3 in the domain. So we say f of 3 is the functional value of f of x for x equals 3. So letters other than f can also be used to name functions. That part isn't something to get hung up on. You'll see g of x or h of x or c of x or even other letters. It could be of n, c of n, f of n. Those again are just variables used to represent this function or this rule that we'll be writing. The ordered pair 3, f of 3 is a solution of the function f in the previous slide. So I'll go back up there and show you. We had this f of x is equal to 2x plus 1. Okay, so when this f of 3, we have x is equal to 3, then that output value will be equal to f of 3. So you can determine that range or that output by substituting in 3 for x. So you can see that right here. I'm going to kind of highlight this for you. Right here. So we've taken the original function and we have substituted in x is equal to 3. So 2 times 3, which is 6, plus 1 is 7. So we could also state that f of 3 is equal to 7. Therefore, looking back at this ordered pair, we would have 3, 7 to graph on the line. When x was equal to 3, the output was equal to 7. Okay, so let's look at example 3. So we'll be making a table from a function rule. So make a table for f of n is equal to -2n squared plus 7. Let's use 1, 2, 3, and 4 as the domain values. So this is like a function machine, right? We'll make a table, we'll have our input, which is our n value in this case, we will apply the rule and we will get the output or the range. So here's the table. So a lot of times if you want to, you can make it like 3 columns. So you have your input on the left-hand column, the 1, 2, 3, and 4. The rule was established and is right here so that you could substitute in the values for n. So you'll square n, take it times -2, and add 7 to get your output or your range. All right, to find the range, evaluate this function rule. F of a is equal to -3a plus 5 to find the range of the function for the domain of -3, 1, and 4. So again, they're giving you the input values they want you to use. You need to come up with the output or the range. So f of a is equal to -3a plus 5. You could set it up as a table when you're doing this type of example for sure, but I think they kind of wanted you to use this notation as the range. We talked about that with the brackets. So you can substitute in the -3. You can see that right here. You can have the 1 when you use the 1 for the value of n, or the 4. And you get your range. So example 5. If f of x is equal to 3x minus 7, find each of the following. So we have the same rule, and now we're going to find f of 2. So we would take 3 times 2 minus 7. So 6 minus 7 is equal to -1. 3 times 5 minus 7. So 15 minus 7 is equal to 8. And 3 times -3 minus 7, so -9 minus 7 is -16.